This is problem number 1 from section 2.5. In this problem it says, use the function and graph to answer the questions about existence, limits, and continuity. So one thing that we want to define for this problem is what does it mean to be continuous? So this is essentially a shortened version of the definition of continuous. So a function is continuous. Write that a function is continuous at a point C if the limit as x approaches C for the function is equal to the function defined at point C. Meaning, if the function is defined at point C and the limit as x approaches C is the exact same number as the number the function is defined at, then we have a continuous function. So let's go ahead and look at the questions and determine, using this definition, whether or not that function is continuous. So it says, does f of negative 3 exist? So we go to negative 3 and we look right here. So if we go up from negative 3, this is where we intersect that line. So does f of negative 3 exist? Yes, it does. F of negative 3 is 2. So we can say that f of negative 3 equals 2. And the answer to that question is yes. Does the limit of f of x exist as x approaches negative 3? So as we approach negative 3 from the right and from the left, we're approaching the value of 2. So the limit as x approaches negative 3 of this function equals 2. Now notice that it's defined at negative 3 and the function value is 2 at negative 3, and the limit as you approach negative 3 of that function is 2 as well. So then it says, does the limit of f of x as x approaches negative 3, I should say yes here, but does the limit as x approaches negative 3 of f of x equal f of negative 3? The answer to that question is yes, and because they equal each other, we go back to this definition, we can now answer the question, is the function continuous at x equal negative 3? Yes, it is continuous. This function does not break. It is continuous at that point. Now let's look at some other spots in this function where it would not be continuous. Real quick, let's look at the x equal 3 spot. So let's say, what is f of 3? And then what's the limit as x approaches 3 of the function? So as we look at f of 3, it's not defined here, it's actually 2. F of 3 is 2. Well, what's the limit as we approach 3? As we approach 3 from the left, we're getting closer to a value of 4, and as we approach 3 from the right, we also go toward that same value of 4, so the limit as x approaches 3 of the function is 4. Notice these two numbers are different. This does not pass the definition for being continuous, because the function is defined at f of 3 to be 2, but its limit is 4, and because those two things aren't equal, we can see from the graph it's not continuous. It has an open dot right there, so the function does not continue fluidly throughout the x values 1 to 5. And so we can say that the limit here would not exist. So not the limit, the function isn't continuous. Continuous at x equal 3. So this was an example of when it is continuous. This is an example of when it wouldn't be continuous. And we can see that it's not continuous here because it's not defined at x equal negative 2. It's not continuous here because it's not defined at x equal negative 4. And it's not, it is continuous down here at these 2 points because it's defined there and the limits would be the same. So that's the key here, is taking this definition and applying it to different parts of the function to determine whether or not they're continuous.